Morning. Today I just wanted to provide you some resources to help you solve some application problems with exponential and logarithmic equations, specifically exponential models, but possibly using logarithms to solve. You saw a lot of these formulas in Algebra 2, so that's why I wanted to do a quick review. This is your general simple exponential growth and decay problem. If it's growing, we're going to add. If it's decaying, we're going to subtract. This little a is always your initial amount. A of t is your final amount after a certain amount of time. R is your rate of increase or decrease. Don't forget to change it to a decimal. And t is the number of time periods. There are some keywords for simple growth so that you know that's what you're using. You're looking for grow, increase, acquire, gain, incline, save, and invest. And for simple decay, you're going to look for decay, decrease, depreciate, decline, lost, dropped, etc. Two other formulas. We have compound interest. P is the principal or the starting amount. R is your rate of increase or decrease, which is written as a decimal. N is the number of times something is compounded per year. N is the number of years, T is the number of years, N again is the number of times compounded per year, and A of T is the final amount. Annually means once a year, semi-annually twice a year, quarterly 4 times a year, monthly 12 times a year, weekly 52, and daily 65. But you will see compounded blank times per year. And then half-life is one that you'll see either with the fraction 1/2 or the decimal 0.5, something that'll come up a lot in science. We have an initial amount, which is your little a, final amount is your big A. And then half-life, because we're cut in half. And then t is the amount of time that's passed, and t sub h is the length of the half-life. Okay, we're going to go through and do some problems here, and then there's some practice for you to do. There will be a couple of these problems on your test, like I said, so just make sure you're careful with these, and we will review them as we need to. Okay, so we are going to write an exponential model, unsolved, and then go ahead and find our answer here. So for the first problem, Cal bought a Dodge Ram 1500 Bighorn for $29,700 in the year 2013. At the rate Cal puts miles on his truck depreciates, keyword there, at a rate of 6% per year. How much will Cal's truck be worth in 2020? Okay, so our starting value is $29,700. The rate is 6%. So let's go ahead and set this up. The final value is going to be our initial value times 1 minus 0.06. Remember to change that percent to a decimal to the t power. Okay, this is your model. To figure out your actual answer, t is 7 because it's been 7 years. So go ahead and plug in 7. Type all of that in your calculator. So 29,700 times 1 minus 0.06 in your parentheses to the 7th power, and you get about $19,259. Switch my numbers there. And 78 cents. Okay. Next one. In the year 2010, Posh Chicago collected data that showed 2,112 stray cats. So that's our starting amount. Roam the streets of Chicago. Over the years, Posh estimated the population has continued to increase, so growth, by 0.08% each year. If this trend continues, how many stray cats will there be in Chicago in 2018? Okay. Starting amount 2112. We are increasing at 0.8%, so that becomes 0.008%. Move it 2 places to the right. To the left, to the t power, and then 2018 minus 2010 gives us a t of 8, so go ahead and plug that in, 2,112, 1 plus 0.008, in parentheses, to the 8th power, and you get about 2,251 cats. Remember to round to the nearest whole number, because we can't have part of cat. Okay, next one. You invest $5,000 into an account, that's your principal, with Edward Jones that pays 1.2 annual interest compounded weekly. Find the balance after 3 years. Okay, so our final amount is going to be the principal, which is 5,000. So I have 5,000 times 1 plus, and then our rate is 1.2, so 0.012 divided by compounded weekly is 52 weeks in a year. And then N, which is 52 times T there. So there's our model. Now we're going to go ahead and plug in 3 here for our T. So if you plug a 3 in there and type this in your calculator, 5,000, parentheses 1 plus 0.012 divided by 52 to the 52 times 3 power, it will be about $5,183.26. Okay, next one. In 2000, you buried 15 kilograms of carbon-14 in your backyard. Someone digs it up in the year 13,460. How much carbon-14 did they find? There's a half-life of 5,730 years. Okay, so we want to find our final amount. We are starting with 15 kilograms. It is cutting in half using half-life. We are going to do T divided by 5,730 there. So it has been 13,460 minus 2,000 years, so 1,160. So we are going to type this in. We're going to do 15 times 0.5 to the 11,460 divided by 57,030 power and get our final answer. We need to type that in. Got an extra 1 in there. It didn't work. Delete 1,000. There we go. And it will be about 3.75 kilograms. That one takes a really long time to break down. Okay, 4 more. In this, we're going to find a lot of time. Okay, so if we deposit $5,000 into an account, we are paying 6%. Helps if I put it in the right spot. $5,000 into account, paying 6% interest. We want to know how long it takes to accrue enough to have $8,000. So this is what this one's going to look like. 1 plus 0.06. Compounded monthly, which is 12 months in a year, to the 12t power. We're going to simplify this. So I have 8,000 equals 5,000. And I'm going to plug that in my calculator. 1 plus 0.06 divided by 12 gives us 1.005 to the 12t power. Now we need to solve this using exponential equations. So we're going to divide by 5,000. So I get 8/5, or a decimal either way, equals 1.005 to the 12t power. We're going to use a logarithm. 1.005 of 8/5 equals 12t, and then we're going to divide. So we're going to type this in our calculator. 1.005 of 8/5, and then divide by 12. It takes about 7.9 years. Okay, make sure you divide by the 12 afterwards. Okay, next one. A coin had a value of $1.17. It's been increasing at a rate of 9% per year. We don't know how long, but they want to know when it'll be worth $2.75. Okay, same idea. We're going to simplify and divide. I'm actually going to do that in the same step. So divide by 1.17 to get 2.35 equals 1.09 to the t power. Rewrite it as a logarithm. And type that in your calculator. So we're going to go math, log base 1.09 of 2.35 gives us 9.9 years. So that would be 2004 for a final answer. 2004, 2005. It happens towards the end of 2004. Last two. An isotope of cesium-137 has a half-life of 30 years. How long will it take it for a 2.5 gram sample of cesium-137 to disintegrate to 0.25? So we're going to do T divided by 30 there. Same process. Divide by 2.5. So 0.25 divided by 2.5 is 0.1. 0.5 to the t divided by 30 power. So we have log of 0.5 of 0.1 equals t divided by 30. So math, enter, 0.5, 0.1, and then times 30. It's going to be about 99.7 years. Okay, last one, same idea. This time we are going to purchase equipment. It is depreciating at 18% per year. We don't know how long it'll take until it's only worth $4,000. Simplify, divide, and then logarithm. Okay, so log base 0.82 of 0.229 equals t. And we get about 7.4 years. So, in 2017. Okay, that's all you're doing today. Like I said, you've probably seen all those in Algebra 2. Wanted to just review them quickly so that you can see those applications of those formulas and go on from there. Let me know if you need help. Have a great day.